In today's lesson, I'm going to show you how to use trigonometric ratios to solve unknown sides. So I've uploaded the trigonometric ratios on the top of your screen, and usually we shortened these relationships using SOHCAHTOA. So that's what you're familiar with. So before we can solve for any unknown sides, we need to actually identify the sides and its relationship to the given angle. So if you're looking at the first diagram here, you can see that we have an angle that is 60 degrees and two sides. So what we need to know is what are the two sides, what relationships do the two sides have with this angle. So if I drew an arrow from the 60 degrees and it hits this side here, we know this side must be the opposite side. And if I drew the arrow from the right angle and it hits this side, it's the hypotenuse. We also know it's the hypotenuse because it's also the longest side. So the reason why we need to identify the sides and its relationship to the angle is we use these two pieces of information to work out which appropriate trigonometric ratios that we use. So writing SOHCAHTOA out, I can see that the two sides that have information, or the two given sides, are opposite and hypotenuse. So we go back to our SOHCAHTOA and we can see that SO has opposite and hypotenuse in the relationship. So that means we're going to be using the sine ratio. So that sine theta is equal to opposite over hypotenuse. So remember, the theta stands for angle. So I'm substituting the angle with 60 degrees, so it's going to be sine 60 degrees equals to opposite. So looking back in that diagram, opposite is A, so we substitute A for the opposite side, and the hypotenuse is 17, so I'm going to substitute 17 for hypotenuse. So now what we've done here is we actually establish a trigonometric ratio, and from this trigonometric ratio we're going to use it to solve for A. So A is on top, so A is the numerator, and so when A is the numerator, the easiest way to solve for A is to actually times the denominator over. So to solve for A, therefore, A is the same as 17 times sine 60 degrees. So you can do this all on your calculator and you should get 14.7224318. And since the question's asking us to one decimal place, we round it off, so it's 14.7 centimeters. Okay, so moving on to the second question. So scrolling down to the second question, what we have here is we have an angle that's 50 degrees in 13 minutes and we have two sides. So what we're going to do is, before we begin, we need to identify the sides and its relationship to the angle. So this is our angle here. You can see right away the longest side is the hypotenuse, and the hypotenuse is represented by the letter B. And that shouldn't be there. Hypotenuse is represented by the letter B. And this side here, this side is not opposite the angle. It's actually adjacent to the angle. It's right next to it, so it's the adjacent side. Now what we're given is, we're given adjacent and hypotenuse. And if we write the SOHCAHTOA relationships out again, we can see that the cos relationship is the one that uses both adjacent and hypotenuse. So we're going to be using cos theta is equal to adjacent on hypotenuse. So now once we establish which trigonometric ratio we're going to use, we're going to substitute our given information. So instead of theta, we're going to have cos 50 degrees and 13 minutes. Instead of adjacent, it's going to be 3.8 meters, and instead of hypotenuse, it's going to be B meters. So now what we're doing is we're solving for B. B is what we want to know. B is our unknown, and because B is the denominator, the easiest way to convert the denominator as a subject is to switch it. So I'm going to switch B with cos 50 degrees and 13 minutes. So now B is the subject, so B is by itself, and now it's going to be 3.8 divided by cos 50 degrees and 13 minutes. You can do this in your calculator to get your final answer. So on the calculator, you input those given information, and your answer should be 5.93855663, and the question wants us to round off to one decimal place, so it's going to be 5.9 meters. So that's your final answer. So in the next video, I'm going to show you how to solve for unknown angles using the trigonometric ratios.